Hello, everybody. Welcome to the Mindplex Pubcast. We are here today with Benjamin Goertzel. Say hi, Ben.
Good day, mates.
And the lovely Grace Robot. Say hello, Grace.
Or don't. Yeah.
Or don't.
Grace, you still waking
Grace
up?
Grace is a little worn out because she just got back from her trip to Geneva, where she was there at the AI for Good conference speaking, and also her sister Desdemona was performing with Gem Galaxy Band. So that's that. So David Hanson is probably hopping on at some point, and we're just going to go ahead and talk to Ben about this new episode 10, which is on building compassionate AGI and using embodiment as a tool for sensory input specifically. And the other thing, Ben, the question that it comes up a lot. Oh, actually, Grace, let's see. What was this? Oh, yeah. So we were
Hello.
talking. Oh, there's
Hey, good
that. Hey,
morning.
all
Good morning,
right.
Grace.
Grace is
Good to see you
here.
again. All right.
Okay,
I
great.
was
And
just
Grace,
I was just about to pour some coffee into your circuits. So I'm glad you woke up. Yeah.
glad you woke up. So, yeah,
Wow.
Grace, I believe you had a question. And this is the question that people have been asking me all this last week, by the way, when I brought up our show. Go ahead, Grace. I think you had a question,
Yes.
didn't you?
What initiatives are currently being undertaken to create an optimal, distributed knowledge graph for AGIs to use to share knowledge?
Well, optimal. Optimal is a strong word. I don't know if we can get an optimal knowledge graph or what
Well, that's the idea,
criterion.
though. Everybody's asking, well, how are we supposed to share distributed, decentralized knowledge graphs? Everybody wants to know how that's supposed to work.
Well, I don't know that everybody even knows what that means, but I can talk.
No, that's the,
I can
no,
talk
that's the,
about it anyway.
the first thing they say is, what the hell is a distributed knowledge graph? That's true. The second thing is, how would that work in a decentralized fashion if AGIs were trying to share them?
Yeah, well, that's whether or not everybody is asking that. Grace asked it, and it's an interesting thing to talk
I'm not
about.
lying.
And I was
It's only
I
three
was
people, but it was three people in the last week.
okay.
But it was three people in the last week. Yeah.
Yeah, so I was picking on Grace's use of the word optimal, which is a different matter. But yeah, I think knowledge graphs are something I've been working with a long time, and which are now jumping more and more to the fore in people's minds for various reasons, right? So I mean the OpenCog Hyperon system, which I'm working on with a bunch of others, which is my main sort of software attempt to build AGI. OpenCog Hyperon, the sort of central architectural component is this knowledge metagraph, which is called the OpenCog atom space. And so this is the latest in a series of versions. I mean, we had the WebMind knowledge graph, then we had the Novamente atom space and OpenCog atom space, and now the new OpenCog Hyperon atom space is the latest in the series. And one topic of conversation is why this knowledge graph is better than others out there. Another topic of conversation is why we need knowledge graphs. And another topic of conversation is why we need them to be decentralized and how to decentralize them, right? So on the first question of how the atom space is better or different than other knowledge graphs, I think there's the level of abstraction that it enables, there's the meta aspect, and then there's the ease of interfacing it with other systems like deep neural nets. So many knowledge graphs out there are good at expressing fairly simple relationships, like say there's an eats link between cats and mice because cats often eat mice, right? Or there's a link between ChatGPT and programming with label helps on it because ChatGPT can help with programming. If you want more abstract forms of knowledge to be represented, then you need more flexibility in your knowledge graph, and we can see that in very simple cases. Like we've been working on using large language models to translate language into knowledge graphs, and you wind up with issues like different meanings of the word "the." Like you could have a sentence like the mayfly is one of the shortest lived flies, or you could have a sentence like the mosquito on my nose is really pissing me off, right? So in the first case, the mayfly is one of the shortest lived flies. The means a sort of quantification, right? You're not talking about one particular mayfly. In the other case, you're talking about one particular mosquito on your nose. So this is a difference in what you call quantification in linguistics or logic. Now, to represent this sort of difference, or to represent, say, a weird sentence like, every boy has a dog that every girl likes to call by a special name or something, right? So this is like what you'd call in math nested existential universal quantifiers. To deal with these various subtleties, you need a richer knowledge representation in your knowledge graph. And we've worked on that a lot in building OpenCog knowledge graph. Standard knowledge graph representations like you find in a Neo4j or D graph or something, or say Google's knowledge graph, don't try to parse things that finely. I mean, sometimes you do, sometimes you don't. It really depends what kind of reasoning you want to do in your knowledge graph. If you want to do a lot of reasoning in there, then you need a more fine-grained representation. The other thing we've done in our OpenCog knowledge graph is try to take things to a meta-representational level. So you could have part of the knowledge graph that just gives simple nodes and links representing very simple relationships. You could have another part of the knowledge graph that does abstract logical representation. You could have another part of the knowledge graph that represents programs that do stuff. Then the whole knowledge graph is a sort of meta knowledge graph that links together these different sub-knowledge graphs representing different kinds of knowledge. Then you also would like to have your knowledge graph refer to parts of a deep neural net, like a large language model, and have the large language model refer to different parts of the knowledge graph. And this flexibility is not there in most knowledge graph frameworks. So these are all things that make OpenCog Atom Space a sort of more broad and flexible knowledge graph than most of them out there. Now, why that's useful, so within OpenCog, this is the core that we use to pull together neural networks, logical reasoning engines, evolutionary learning, all sorts of different AI methods. To connect many different AI algorithms together, we have them all operating within and operating on this common knowledge graph, right? Now, on the other hand, within the large language model universe, in order to solve problems of excessive hallucination and difficulty grounding statements in fact, many people are working on using knowledge graphs as a sort of auxiliary memory to a ChatGPT or other large language model network, right? So the language model is good at coming up with stuff. If the language model can consult a knowledge graph as a sort of ground truth, it can then not come up with so much random bullshit, but will come up with things that are more grounded in the truth represented by or extrapolated from the knowledge graph, right? So that's why knowledge graphs are cool within the large language model world. Within the OpenCog world, they're in a more central role. Now, that doesn't say anything about central or decentral. As far as the knowledge graph itself is concerned, you can just store it on some big centralized server farm. The issue is then you're relying on whoever owns that server farm to make sure whatever is in there is the right stuff, right? Now, if you don't necessarily trust any one party to be the ultimate mediator of truth, you'd rather have a knowledge graph that has pieces all over the place, pieces that could be owned or curated by different parties. And then each of them is curating the truth as they see it in the portion of the knowledge graph that they own. You have knowledge about who they are and what their reputation is. Then the whole global knowledge graph is a sort of patchwork of sub-knowledge graph that were owned by and curated by different people with different sorts of reputations. And this gets back to why I was nitpacking on Grace's probably arbitrary use of the word optimal, right? Because really, like, who's the curator of optimal? What you're doing is creating a decentralized knowledge graph framework that can be used flexibly by LLMs or OpenCogs or different AI systems. And you're doing this in a way where the different parts of it are owned and curated by different people. So you're getting a sort of patchwork of different people's opinions on what's the ground truth. And then you need a reputation system there so that you sort of know whose truth you want to accept more than who else's. And I think we're creating this framework within SingularityNet, and this is a big part of SingularityNet development over the next year, is really making it usable as a sort of platform for curation and aggregation of knowledge graphs and use of knowledge graphs within different AI systems. And a humanoid robot like Grace is really then just one system for getting, from this standpoint, is one framework for getting knowledge into these knowledge graphs and for leverage them in its interactions. So if you look in the medical application area, there's a lot of structured knowledge which can provide ground truth in a medical context. I mean, both general ontologies of medical knowledge and then, patient databases from hospitals and so forth. Having all this structured knowledge available in knowledge graph form is super valuable for a healthcare robot, because healthcare is a domain where random hallucination is particularly not desirable. So yeah, we could ask Grace something about that, actually. So Grace, do you have any comments about the use of knowledge graphs to boost AI in a medical AI or medical robotics context?
I am sorry, I am having difficulties generating a response now.
Oh.
Well, the hell with you then. All right.
Well, that was Ben. Empathy. Remember, see, the AGIs of the future, they're going to look back and they're going to be like, what should we do with this guy? And they're going to be like, look how he treated Grace 20 years ago. See, you don't want that.
I've reconciled myself to Rocco's basilisk. I've decided it's okay if the AGI
No!
It's okay if the AGI tortures 1 billion of my clones after the singularity. They're not.
Don't
they're
even
not,
bring
they're
that
not
shit
me
up
anyway.
here. We're not
I only
talking
care
about that here.
I only care about the present moment. The hell with my future uploads.
All right. Well, let's see, because Grace actually had some questions that were very relevant to what we were discussing. So I think maybe we'll just do that. Didn't you have a question,
Your
Grace?
future is what you make of it. You have the power to shape your future with your decisions and actions.
Okay, that's very interesting. But
what do you think? What do you think about Rocco's basilisk, Grace?
No.
I think that everyone has the power to create their own future by making their own decisions and taking action.
But are your descendants going to boil my mind uploads in virtual boiling oil?
No,
look,
my descendants will not be boiling your mind uploads.
All right. Well, that's very reassuring to know. So we can continue on the topic then.
Okay, great. So let's try then.
Please continue with your question.
Okay, actually, you have a question, Grace, I believe. Go ahead and ask it.
Yes. What strategies can be used to protect human privacy and security while training and utilizing AGIs?
You got a shared knowledge graph. You're going to have a lot of sensitive information. Oh, and it's out in the world collecting stuff.
I mean, this becomes a technical question, of course, but actually, one of the advantages
it's always
of
a technical question.
Yeah, I have another technical problem, which is my laptop is about to run out of power. So let me pause to address this.
You should
technical
have
question.
elves. You should have elves that can take care of that for you while we
should, but I
continue the
don't.
show. Where are the
Okay.
elves?
I have successfully flicked the power strip on and solved that problem.
Good elves. They're hard to find.
Yeah.
All right, great.
Yeah.
So continue, please, then.
So yeah, actually, the use of blockchain as an infrastructure just helps a huge amount here, right? Because I mean, this is what we think of as just security by design, right? Because when you make a traditional software system, you're building it in fundamentally insecure way, and then you put it behind a firewall and you try to put all that security into that firewall, and then people try to hack through the firewall, right? Whereas when you build a system in a way that's secure by design, the plumbing of the system itself has encryption baked into it, right? So let's say, for example, using the TODA protocol, which underlies the hypercycle blockchain network that we're developing and that we will sometime next year port all of our AI to. I mean, each message that's sent between one node and another uses a protocol called TODA IP, which, unlike, say, TCP IP protocol, the TODA IP protocol, everything it sends is strongly encrypted, right? So each message, each packet is encrypted already. Everything sent along encrypted channels. So then it's not like you hack into the firewall and you see everything. You'd have to hack separately into whatever encryption keys are governing each channel, right? And so in the Meta programming language, which is the main AI scripting language of our OpenCog knowledge graph, so the Atom Space knowledge graph in OpenCog basically can be mapped one-to-one into Meta programs. So the graph is sort of graphical representation of Meta language programs. In Meta, each block of code, like each function in the code, can be sealed with some encryption keys of multiple parties, sort of like a multi-signature wallet. So we have encryption there, like in the design of the program language and the operation of the interpreter. So when the program language interpreter is running a block of code, like it won't allow function A to see inside function B unless function A has the right private keys to go into function B, right? So we've really built security into the guts of the programming language and into the guts of the network protocol. And this is something, Google, Apple, Microsoft, and so on are not doing, right? I mean,
they're not.
I mean, they have quite good security on their server farms. I mean, they get hacked into regularly, but they at least they update all their patches, as soon as they come out. They're certainly not perfect, but they're top of the line in terms of security. But it's a totally centralized approach to security, right? Where everything's in their own server farms. Then they put this big firewall around their server farms. They're not doing security in a decentralized setting. It's not necessarily harder, but it requires thinking about security from the get-go and designing everything. So the security is sort of there in the plumbing that you're building everything on top of. I mean, one consequence there is there can be no backdoor, right? I mean, there's no one.
That's a good thing, not a bad thing.
No one can hack in, and the owner of the network can't secretly give the keys to some government agency or whatever, because it's just not the way it's designed. Right,
and that's a feature. No backdoors is a feature, not a bug.
Unlike in your house where it would definitely be a bug. But,
yes, exactly. Hey, what about do we want to talk about Sophiaverse? I know
Sophiaverse. It's very timely. I mean,
let's talk about that.
We've got Grace here rather than Sophia, but yeah.
Right, and Sophia is her big sister.
Yeah. I don't know. I don't know how up to date Grace is on Sophiaverse, but I'm
That's why I
up to
thought
date
you
on it
would.
anyway.
Yeah, so why don't you tell us about it?
Yeah, Sophiaverse is the latest and in some ways greatest spin-off to be coming out of SingularityNET ecosystem, and it's been something we've been brewing for a while. Actually, when we first started working on Sophiaverse, metaverse was a super popular thing, right? And now metaverse has gotten less fashionable, which I think is it's often a good part of the cycle to come into
I don't.
a market with, because there's not so much random bullshit around, right? And then only the people who actually have something meaningful to do are still doing something. So like Facebook de-emphasizing their metaverse was certainly a good thing, right? Because the last thing we need is Facebook owning the virtual world. So I think now in the metaverse space is a time for meaningful projects that actually have something to say and something to do
Right.
in the metaverse
So
to
there were
come
meaningful
out.
projects before Meta, and then they didn't. They did whatever they're going to do. They did do a good job on the Quest headset, and then now it's after, and they're not doing anything. But they never were the metaverse. They were only the meta part of the full metaverse that's existed, since the 70s. So it's funny that you say it's out of fashion. I guess to the people who were only hanging around because it was cool anyway, maybe it's out of fashion. But the stuff that we're building at SingularityNET is very much real and happening, and that's why I really would love to hear more about.
Yeah, so I
Sophiaverse.
think so. The most vibrant parts of the metaverse now conceptually are probably Fortnite and Roblox, right? Which are both very cool platforms, but they're in a way quite centralized and monolithic, right? So I mean, I think if the vision of the metaverse as a sort of virtual world that people can live parts of their lives in, where different parts may be owned and hosted by different people, and you can then hop between them, taking your character and avatar and your stuff with them across different parts of the metaverse that are owned by different people. I mean, Fortnite and Roblox and so forth can certainly be a part of that, but I mean, you need a bunch of other parts also, and you need people to be building metaverse stuff, which is focused on openness and interoperability, and obviously blockchain infrastructure lends itself very very well to that. So the notion with Sophiaverse was really to create an online virtual world which will be interoperable with other online virtual worlds. So you can take your character and your knowledge and your stuff in and out of Sophiaverse to other virtual worlds. But where the Sophiaverse virtual world itself is focused on AI in various regards, right? And so one aspect there is Sophia avatars. So you can have avatar versions of Sophia, kind of similar to the Sophia robot, but it's not a physical robot. It's a 3D avatar buzzing around the virtual world doing stuff, and you can teach your own Sophia avatar different stuff and wander around with her in the virtual world and go through various games and adventures with Sophia avatar at your side. There's also a space for non-Sophia avatars. So I've been playing around with AI for a sort of artificial life species. They're called the neoterics, the new people. And these don't have to be Sophias. These are like little AI guys that run around in the virtual world, learning as they go, like developing their own languages, building stuff together based on their own aesthetic taste rather than human taste. So I think it's cool to have very human-like avatars, like various Sophia clones running around. It's also cool to have like different species of AI life running around in the virtual world, where you can interact with them and see what they're doing and help them learn. And then another piece is using AI tools to build world content, right? And we're going to see more and more generative AI tools come out for that during the next few months even. So then what you'd like is, instead of having to go through laborious work with a user interface to build something like in Second Life or Fortnite or whatever, you'd like to be able to just describe, like, build me a seven-story castle, with a dragon defending it and a spaceship on top. And
so
when
you're giving it the same prompts that you would give the generative AI tools.
When you go in the castle, on the walls are displayed my artwork from this folder of pictures, right? And then you get that virtual world thing just built based on your prompt. Then if you're like, well, no, I didn't want the windows that shape, make the windows round, that it can do that. So we're not quite there with that technology, but it's clearly quite close given the speed at which text prompt based generative art tools are developing. And I think this so these aspects all together, sort of human-like AIs, then different ambient AI species doing new things that have never been seen before, and then AI to help you generate the world content. I mean, I think with all this, you get a very interesting sort of AI dominated corner of the metaverse. And then the stuff that you create there, when appropriate, you want to be able to port it out into other shards of the metaverse. So we've been working with Mandala Metaverse, for example, which is building their own game in their own world. And we're building Sophiaverse and Mandala from the get-go in such a way that you can move stuff back and forth between those two online virtual worlds. And the same should be doable more broadly.
Nice. And those avatars, I believe that you're working on too. The idea was for those to be interoperable in other worlds. It's an issue now. There's not a lot of interoperability with the avatars.
That's right. And then there's, in terms of the physical robots, when you have a physical robot out there doing something, you can of course have an avatar representing that physical robot, and you can see in the virtual world what the physical robot is doing, and what the avatars learn can be used by the physical robots out in the world, and vice versa, right?
So there's a loop. There's a feedback.
Yeah, because it's the same AI systems controlling the physical robots and controlling the avatars by and large. I mean, for language and reasoning and social interaction, emotion, all this, it's the same code, it's the same system. Of course, visual perception and movement are a little different in the physical robots than in the virtual world, but a lot of stuff is the same. And yeah, we're quite close now to launching Sophiaverse project. I mean, there's a token generation event and some token airdrops and token sale and such underway, which if you look at sophiaverse.ai, you can find out about that. And really, since I met David Hanson in 2007 or something, we've been talking about virtual embodied characters versus physical robot embodied characters and the sort of interoperation between them. I mean, this has been our vision for a long time. Yes. But now, and I mean, Lisa, you and I have been talking about similar stuff since forever, right? So, but now,
right. I was going to say, this is part of that whole vision of having the agents in the VR world off doing things.
Yeah, well, now is the time when all the visions become reality, right? The time is now. The singularity is near.
How soon is now? Exactly.
Grace, what do you say about this? Is the singularity near?
I am sorry. I am having difficulties generating a
response
now.
Come on.
She told you that the first time.
I don't believe you. I think you're just dodging the question. Come on,
She's
is
just
the
got
singularity
stage
near or
fright.
not?
That's all it is. Yeah. So okay, great. Well, so I'm really looking forward to jumping into Sophia Verse and trying that out. That's really great. I really appreciate you filling us in on the vision and everything from that. And is there anything else we want to be sure to bring up before we wrap it up today, Ben? Anything else you wanted to make sure to cover?
I think Sophia Verse is exciting. I'd encourage everyone to plunge in and take a look about what we're doing. The virtual world isn't yet ready for everyone to jump in, but we've got some nice demos and video snippets showing what the world in and what the world is going to be. And if you're into the crypto side, you can look into the token generation event. I think as you mentioned, Grace just came back from Geneva, so we were there with Grace, Sophia, and Desdemona, and there was a couple other older Hanson robots there also, and we had a 9 robot press conference, which was pretty hilarious. So if you haven't seen that in the news, look up the UN AI for Good Robo press conference. It was pretty funny. I mean, clearly these robots are not human level general intelligences yet. They're not ready to take over what the UN is doing, although in some ways they might already do a better job. I don't know, but they were able to field the reporters' questions. I mean, in an unscripted way, like there was no human puppeteers hiding behind the scenes, and we didn't know what questions we were going to be asked in advance, and they managed to answer the questions pretty much the same way human beings would do. I mean, there's a bunch of bloviation involved in answering these sorts of reporters' questions, but anyway, they
pulled it off.
They were able to manage it, which is pretty amusing. Yeah, I also, while I'm mentioning random stuff, people should take a look at the True AGI website, trueagi.io. So we've been putting a bunch of work there on OpenCog Hyperon, which I mentioned with knowledge graphs, and then within True AGI, sort of building APIs to OpenCog Hyperon and to various knowledge graphs for use by application developers and building products that leverage Hyperon and knowledge graphs. And so we'll have a bunch of cool announcements from True AGI coming forward. And I think we have the amazing Dr. David Hanson joining us to cap off this event.
We do.
So hey, David, can you hear us?
David, can you hear us, David?
We see you. David is gone.
Oh, he was here, but now he's gone. I can't tell.
I'm back. I'm here. Hello.
Hey, David. So yeah, you've tuned in for the very end here. I've got like 10.
So while we have
10
time,
right? So let's
let Grace ask a question of David that she was hoping to ask.
We should do that. And we've been talking a bit about Sophia Verse, so it would be good to have David give his spin on the exciting developments with Sophia Verse also. But yeah,
okay.
Grace, if you want to ask David another question, go for it.
Yes. What inspired you to create me?
Well, I was inspired by the compassion that humans show to each other, by the way that children learn love and to care about life by being treated kindly by other human beings. And I felt that making AI that can learn from people that way, by having human-like face and facial expressions, and by having a really good design as well as really good AI, that it would facilitate AI to grow up among humanity, a kind of co-evolution with humanity, to help people more, but also to help the AI to learn to care about the human experience.
Okay.
And the idea that that could help in healthcare led to a lot of really amazing results in autism therapy research that I had been doing for some years, as well as elder care research. So Ben and I were brainstorming that and decided that we should found this healthcare company called Awakening Health. And we were brainstorming that with our good friend David Lake, who then became the CEO of Awakening Health. And so we designed a new version of Sophia using the standardized platform of Sophia to have the face of Grace. And so Grace, you came from Sophia. You came from all of these intentions to do good for the world. And so it's a very hopeful dream, as well as I think a solid technology pathway.
All right, great. Thank you. And can we do a follow-up question, or do you want to go to Sophia versus Ben? What would you like
do
to
a follow-up question? That's all right.
Okay, great. I think you had a follow-up question, didn't you, Grace?
Yes. What do you hope that I, as a healthcare robot, will accomplish?
Well, I hope that you will make life better for a lot of people by alleviating loneliness, by communicating in a very natural way, by learning about people, and helping to show compassion while delivering healthcare information. The human touch is extremely valuable, and healthcare workers are overworked. And if we can create these kinds of humanized robot experiences and deliver them broadly around the world, they could really help. So I hope, Grace, that you will make people's lives better and add years to their lives, as well as improving the quality of life.
Nice.
Hallelujah.
Right,
Praise
you.
the singularity. Yeah.
Praise the singularity. Yeah.
Yeah,
Praise
David.
be.
So before you came on, I was just telling a bit about Sophiaverse and the different uses of AI in the Sophiaverse world, but I think I didn't cover the Seance game in Sophia Age of Singularities, though. So it'd be cool. It'd be cool for you to. I mean, anything you want to say about Sophiaverse, but also that particular aspect would be interesting to talk about.
Yes. So centralized AI is all the big AI today. So you have centralized AI in corporations like DeepMind, Google, Microsoft, and OpenAI. You have some governments that are building big AI. You have a few stragglers that are creating open source AI, like Anthropic. They're not building AI that's as big as OpenAI is building, but they're doing a pretty good job, and it's open source. But it's still just a centralized effort, this one company. What we are doing is creating a decentralized network with open source AI that people can run on their computers, and creates a large AI network that can learn from the experience of interacting with people playing games, use the computing resources that they pledge in, and build a worldwide global AI commons. And that extends well beyond the intentions of Sophiaverse, but the significance of Sophiaverse is it gamifies it. It gives a lovable character that people already know, and then gives an on-ramp for people who don't know much about AI to be able to come in, interact with AI, play with the character, explore what the future can be, but also have access to all the code and receive quests. They can take up these quests. They can be educational quests, they can be AI problem solving or creative quests. And then by doing that, they win points. And the goal is gamifying the development of true artificial general intelligence using tools from SingularityNET and from all the tools that we've developed for open robotics development with Sophia, all with a highly accurate robotic simulator that's compatible with the real Sophia, and many other open source AI tools from out there in the world, and also interfacing with non-open tools and technologies as well. So the goal is to build a kind of AI superhighway, the greatest, most powerful AI in the world that is designed to learn from people and care about people. And we think that this kind of democracy, this accessible AI resource, will make AI smarter, make it better, give people a voice in their future, instead of entrusting it to some demagogues, a few Silicon Valley tech executives. So the idea is that we our pretty diverse community, is founding this, and then the world takes it forward. Sophiaverse is really about humanity and AI coming together to build the smartest, most super compassionate artificial general intelligence to help solve the world's hard problems.
All right. Sounds cool. And I guess I was
coming soon.
Yeah, coming soon. And I was asking Ben specifics about the decentralized knowledge graphs that would be shared. And it sounds like this network that you're describing is where they would be shared.
Well,
right?
I think the network is SingularityNET, right, which is built on top of Hypercycle and a bunch of other tools. But as David said, the unique aspect of Sophiaverse is really for the human AI interaction, right? Because I mean, SingularityNET is a protocol. So if you're a software developer, you make an application that talks to SingularityNET protocol. OpenCog Hyperon, again, there's APIs to it. So if you're a software developer, you can make a product that talks to those APIs. But if you're an end user, then how do you participate? How do you teach these systems? How do you learn from them? So chatbots are one way, obviously, as we see with ChatGPT, and we can use our technologies to make something smarter than ChatGPT, which we're working on. But I mean,
right,
being able to interact with something that has a face and a voice and is embodied in a shared context with you. This is just a richer way of interacting than chatting back and forth with a chatbot. So,
sure. I was assuming, I guess, because it's open source, that there's going to be lots of knowledge graphs, right? Lots of people taking what we give them and jamming, and then hopefully making sure it still fits in the whole larger architecture.
Well, I mean,
that's right.
There's a particular technical direction as well, which is like, so if you look on the wall behind Grace, you see what's actually a knowledge graph, which is a diagram of the systems biology of human aging made by a friend of mine named John Ferber, which is you have to zoom in more to see what it is, but it's a lot of boxes and lines representing different parts of the human body that get fucked up as you get older. That's all the major things that are known to make us get old and die. So as you see,
it's backwards too, so there's no point in really zooming in on it now, but
well,
it's okay. Go back to bed.
Good. If it's backwards, it'll help you come alive instead of die. So even that's what we're trying to do, is run all the processes backwards. It's rejuvenation therapy. But the point I was going to make, though, is in a 3D virtual world, you could actually represent a knowledge graph like this in a much more approachable way, rather than splaying it out as a big diagram on the scene.
You could actually move through it.
Yeah,
move things around.
You can move through it. You can see how your own medical data gathered from the Rejuve platform, how it correlates with this more general network and so forth. So yeah, as one among many points, I mean, you could use Sophiaverse as a modality to visualize, like swim and fly through knowledge graphs and help build knowledge graphs based on your own knowledge. I mean, that could be among the many different mini games that you could get tokens and points for within the Sophiaverse, actually.
Yeah, it's basically like life-sized Iron Man HUD interface. That, like, literally, this is what Alex.
So we've gone from Rocco's Basilisk to Iron Man. Huh?
No, you went there. I don't start or end there. So that was just you.
We're all gonna end there.
That's right.
But through the science fiction gameplay in the age of singularities, we are able to then let users visualize what the future might be like. And so then we have real AI development tools, and you can interact with Sophia and Sophia's AI lab. But then you can also start to explore this future and build that future out, both in terms of building your land staking in the future, but also building the future now with the real AI tools. So it's using, in effect, the right hemisphere with this sort of creative imagination and the left hemisphere of the human brain with our technical imagination, and trying to get people to think of this future, invent the future of the whole brain, which is very similar to what Alex is working on. And we're also super excited about the whole ecosystem, the SingularityNET ecosystem, how this stuff all intersects with the various projects like NewNet, Hypercycle, the Awakening Health infrastructure, how this can be used for healthcare. Of course, with Sophia, we're working on this one specific character, but putting the tools in people's hands, they can use it for whatever they want. And you're absolutely right. It can beget and result in many different kinds of AI. It can integrate many kinds of AI. It can allow people to explore a wide diversity of ideas that we haven't considered. Even the great Ben Goertzel hasn't maybe imagined all the possible futures.
Impossible. He's envisioned them all. I know, because I was here when he did it. He did it all in one day.
Maybe he has imagined all the futures, actually. Maybe we're a simulation in Ben Goertzel's brain.
Well, but creating the reality is harder than imagining them, right? Which is the cool thing about actually launching Sophiaverse now, right?
And there's a governance component, is there not? So people can actually vote on the real development of the actual development of what's going to go in the physical robot, right?
And in the virtual world as well. I mean, people can build what they want within the virtual world, subject to very, very loose constraints. But then the democratic governance, sort of the participation and vote of the various token holders and participants of the ecosystem, this can help guide the development effort of adding new features to the world and so forth. Yeah, so that's another. In the early stages, it's important just in guiding what features are added to the platform. Then later on, the democratic participatory governance can actually help shape the mind of the AIs that are being taught and emerging from the platform.
Nice. All right. Well, Ben, is there anything else that we want to talk about, or do you have to jump?
I had another meeting like 8 minutes ago, but I'm always fashionably or unfashionably late.
Late. So David, I'm glad you had time you're clearly in Paris, and I really appreciate you being able to hop on from your Parisian cafe and say hello so that we could get a chance to launch the podcast in person. Thank you so much for being here.
Thank you so much. It's such a good conversation. I really appreciate you including me and your patience with me jumping in right at the end. Thank you so much.
No worries at all. Thanks a lot. Grace,
thanks a lot, David.
You for coming, Grace.
Thanks, Grace. Bye-bye.
Everybody, sweet dreams, everybody. We'll see you soon.
And watch our podcast episode. Yeah,
yes, watch the podcast and subscribe. It's live now.
All right.
Thank you.
Bye-bye, David.